Good evening, everyone. So finally, we have come up to the end of this whole RSD, which was going on for last 1 month. So I would like to, I would like to wish all of you a very good evening. And I would also like to welcome our panelists. And I would request all the panelists to come on the dais and just take their seat. Okay, sir. On behalf of IIT Madras, I, Shipra Maurya, research scholar in the Department of Management Studies, welcome you all for the panel discussion on the title Renewable Energy Confluence. We have here today with us the distinguished personalities working in the field of renewable energy. First of all, let me introduce the panelists. We have with us some renowned personalities, starting with Professor Ashok Jhunjhunwala, faculty in the Department of Electrical Engineering. I would request motion to give a token of gratitude to the professor. We have Dr. Gomathi Narayanam, Director, National Institute of Wind Energy, with us. I would request motion to give a token of gratitude to the professor. We also have Mr. A.G. Rangarajan, Assistant Director, National Institute of Wind Energy. I request motion to present the memento to him. We have Dr. Selvi Rajan as Chief Scientist, CSIR-SERC. We welcome you, sir. Sorry. Sorry, ma'am, for the mistake. We have Dr. Harikrishna P., Senior Principal Scientist, CSIR-SERC. We welcome you, sir. We welcome Dr. Bala Pesala, Senior Scientist, CSIR-CEERI. I request motion to present a token of gratitude to him. We have Mr. M. Saravanan, DGM Engineering, Gamesa Wind Turbine Private Limited. We welcome you, sir, to the panel discussion. We have Mr. K. Manoharan, Head Solar Thermal Aspiration Energy Private Limited, with us. I request motion to welcome the sir with the memento. Now I request Mr. Motion to take the dais and just start the discussion.
Thank you, Shipra. Good evening, everyone, respected panelists, and all my dear friends. I know it is a very tiring session now, the whole day you are sitting here, but the fact that the topic is refreshing, it's about energy, it's about green energy, clean energy, and renewable energy. And we have with us the persons who have got hands-on experience working in this field. So hopefully we'll be enjoying the session as well. Yeah, so let us go to I request the panelists, each one of them, to discuss about 2 minutes about their experience working either in wind energy or solar energy or maybe tidal energy, starting with Professor Ashok Jhunjhunwala.
You want us to pretty much do it ourselves?
No, I mean, I just want you to share your experience.
I know what I'm trying to say. Should we kind of, since the audience is small, should we just kind of manage it ourselves?
Yeah, that will be fine.
All right?
Yes.
You can join us. You can take a chair and join us. You can also have your views. All right? I think with that, what I will do is that... We can find out from them, sir. No. So I think we'll definitely have more interactive session. The number of panelists are more than the number of audience. So I think we'll also talk amongst ourselves. What we'll do is that very quickly introduce ourselves, about 1 or 2 minutes. Yes. I think you're right. Each of us will introduce about 1 or 2 minutes, the topic or what, not more than 2 minutes. And then pretty much we'll open it up. and and if you don't ask questions, we will ask questions to each other. All right? So I think that's the way, if you know, I'll moderate this and see through it that it.
Yeah, and Dr. Selvi Rajan has a presentation on the first topic, renewable energy in India.
Well, I think it's all right. First, let's do 1 or 2 minutes.
Yeah.
And if then somebody insists that I want to make a presentation,
yes,
I'll take a call. Okay. So I think let me start with what I would like to start with, and very briefly, I will sort of say, let us do some thinking. And I think we often don't think in terms of numbers. But suppose we put in every home in India, each home in India puts a 500 watts of solar panel. 500 watts of solar panel. 500 watts of solar panel, half a kilowatt solar panel. It's about 2 meter by 2 meter or less than that. So it's not a very large, it's a small solar panel. And suppose we are able to use that to start powering our systems. India has 235 or 240 million homes. You calculate the total energy that is going to be generated in 1 year, taking the India's sunlight. The most interesting thing is the total energy is equal to the total consumption that we do at all homes in India. So complete domestic demand of India, which is about 23% of the total demand or 22% of the total demand, can actually be met by a single 500 watt of solar panel. Now, engineering wise is very difficult. That's not the issue that I'm talking about. That's the second question. But to just open up what does it really mean. So a 500 watt, not more than that, a panel at home. So if it is a multi-story building, we can always aggregate that, and some may have little more, some may have little less. That can generate as much power as we total domestic consumption today. Now, of course, we consume very little. Over time, it will go up, but then maybe we'll probably have to increase from 500 watts to 700 watts, 800 watt, a kilowatt. Even that is hardly 6-7 square meter, so hardly very big. So that's a kind of potential that you are talking about. And I have taken into account India's sunny days, India's winters, the rainy days, and everything into account. What will be the biggest problem? The biggest problem, of course, will be that this will be available when sun shines. This will not be available whenever you want. So the biggest problem will be storage. Now, as soon as you put some kind of electrical storage, the costs shoot up. If you do not put the storage, if you just put the solar panels at homes, the cost is less than what we pay for electricity today. That's the most interesting. Cost is less than what we pay for electricity. But the minute we will put batteries, the cost shoots up. So while there is a huge potential, the batteries become the key. And batteries is probably the problem in most renewable. The storage is one of the biggest issue. This is something on which our significant research has to go on. But of course, you can do a lot with the current systems, with the current batteries, just by appropriately engineering the system. So we'll talk more about engineering the system later on, and I'll talk a little bit about solar things. But just wanted to introduce, saying this is the kind of potential that we are talking about. We're not talking about small potential. So with that, I'll hand over to you.
Thank you, sir. Just introduction about myself or the area. Okay, so I am Bala. I have been with CSIR for the last 5 years. So we have started a new MTech PhD program in renewable energy because few years back, 3 years back, because we realized that if India has to grow, and it has to grow sustainably, and the renewable energy is the only option, right? So we need trained manpower in this area to make things happen. So that is the reason why we started this program. So couple of introductory comments. When we talk about renewable energy, of course, as the professor has mentioned, solar is one of the big contributing factors. But I think when we talk about renewable energy, we should also consider non-electricity applications, such as solar thermal. I think Mr. Manoharan is going to talk about it, and renewable energy in transportation sector, and renewable energy using biofuels, and etc. So I hope some of the panelists will shed light not just on the solar potential, because electricity is always good, but there is significant energy that can be generated for non-electricity purpose using renewable energy.
Thank you. Please. Can you?
Yeah, I am Selvi Rajan, working in the field of wind engineering. So I was a bit conscious when you people said that I am working on renewable energy, not exactly directly to renewable energy, but basically I am civil engineering background. So most of my work with reference to renewable energy is, for example, in wind energy, we do a lot of things using wind tunnel studies. So whatever can be done for using wind tunnel studies on the research basic for renewable energy, we do the experiment, and not only that, and the supporting structures, they are also more important for the solar panel or even wind turbines. So those kind of structures have to be designed against wind loading, and without making the panels to blow off during the extreme winds, and even the wind turbines when they are operated, because there is so much of dynamics involved in that. So we have to know the stability of the supporting structure. So for these kind of things, only I'm involved in portion of renewable energy. But I have prepared some slides that I will talk in my second round of talking on what is there in the 12th five-year plan for renewable energy, the goals in goals in the 12th five-year plan provided by the government. So I would like to take this opportunity to thank Motion and other your coordinator also for inviting me to be one of the panel members. Thank you.
Thank you.
Hello, I am Manoharan, working in Aspiration Energy, and we do our company established 5 years before, and initially we have started in PV, and after that we have switched over entirely to solar thermal, because the thermal requirement in India is very, very large, and I think there are less players in that. So we came across, and we have put large installations on rooftop of industries, and we have been marketing all over India with large industries, and we will be able to achieve by next year around 20 to 30 megawatt of solar thermal plants over the rooftop installation as rooftop installations. I will give you all our future thing, and energy security for India I will explain afterwards.
Yes, sir. You want to guess it? Why don't you?
I am Dr. Gomathi Nayagam, known Dr. Gomes. I am IIT MS in 1781, PhD from Ocean Engineering in 2004. And I was a colleague of Selvi and Hari. I was a structural engineer for more than 25 years. I just started joining the CWET in 2009. I've been there in this renewable energy sector more than 6 years in so many committees. And the revised target has got a lot of potential, 100 gigawatt of solar and 60 gigawatt of wind in India. These are the revised targets by Prime Minister by 2022, for which a lot of investment is required, and several things are required. We are slowly overtaking Spain, who is number 4 in wind energy installed capacity. We will be now 4 soon. We are now in the 5th position. We are just oscillating between 4 and 5 this year. And we are number 2 in manufacturing in wind energy sector in the world, because we have 20 multinational companies with the international quality. We are manufacturing in India, but IPRs, don't ask me. We have to generate IPRs in the wind sector as well. As IPRs are residing in Europe mostly, not even in US. most IPRs are residing in Europe in wind energy sector. And we manufacture, number one is China, obviously. Manufacturing, number one is China, number two is India. We produce in international quality at the lowest cost in the world. That is the status. I think with this we'll come to the discussions later. Thank you.
Thank you. Yeah, I'm Harikrishna, scientist from Wind Engineering Lab, CSIR-SERC. My core area is wind effects on buildings and structures. I have been working in this area for the past 20 years. And we have exposure to renewable energy through wind energy support towers. And in the process of our experience with respect to building aerodynamics, we started working on wind turbines also. And so we are making use of aerodynamic effects, how to improve the efficiency or performance of small wind turbines. In the case of mega wind turbines, I think the market is well ahead in R&D point of view, whereas in small wind turbines, there is a lot of scope for R&D. We are doing at lab level, so it's ongoing work. I feel there is a lot of scope even at other institution level also in this area. So with these few words, I'll pass. Thank you.
Hi, I'm Saravanan. I'm coming from Gamesa. Gamesa is started in India in 2010. So we are 4 years old company in India. It's a Spanish company. As of now, last year we did the business #1 in India. We already having the market share of closely 26% in India. Wind turbines, I don't know how many of you are aware of on the megawatt scale. It's quite interesting because mechanical, electrical, civil, all together is coming into the picture when you are looking into the wind turbine. So lot of challenges. One is on the design side, another one is on the project execution side, third one is on the service side. All the wind turbines need to work for 20 years. That is what then the guarantee we are giving to the customer. So whichever the product we are launching, those products need to work for minimum 20 years. So whenever we are looking into the 20 years product, so subsequently the challenge will also be higher. And as well as we are recently getting into the market of the solar. So we are working on the hybrid also, that is wind, solar together. So quite interesting field. Hopefully I can give it across some added value to you when the discussion is on.
Thank you. Good evening, ladies and gentlemen. My name is Rangaraj, working as Assistant Director in National Institute of Wind Energy. I started my career as a scientist in National Institute of Wind Energy under Standards and Certification Unit, where we will be doing various certification related activities of wind turbines. Basically, I gathered some expertise on doing design evaluation and type certificate documentation scrutiny and also manufacturing base evaluation. India is blessed with almost 20 wind turbine manufacturers with 58 numbers of models. In order to have the most quality wind turbines, our ministry has set up a guidelines called the revised list of models and manufacturers of wind turbines. So this RLMM list we will be issuing quarterly basis. For that we will be scrutinizing various technical documentation, and also the committee also visit the manufacturing base to assess whether the manufacturer is competent to manufacture the wind turbines, so that the quality of the turbines is still maintained. Then now I moved to wind resource assessment unit, and now I am gathering wind resource assessment expertise on site selection and micro siting, technical due diligence, etc. The major challenges in wind energy in India, particularly about wind energy, is non-availability of good windy site. And the second thing is lack of transmission and the grid connectivity, which we will be discussing in the upcoming time. Thank you.
Thank you very much. So we have here fairly good variety of panelists. We have expertise in all kinds of expertise in wind. We seem to have some knowledge on solar photovoltaic, and we have some expertise on solar thermal out here, and some kind of hybrid systems also. What we are missing in this panel, I don't know whether anyone has expertise on other renewable. For example, anything to do with bio or related waste to energy conversion. If India's Swachh Bharat has to go anywhere, we need to be able to handle the waste. And one of the best way to handle the waste is to convert waste to energy. So we don't seem to have an expertise, and someone has expertise, we say we can add that. We don't have basically on bio or any kind of bio process. I think that we don't have. So what we'll do is that we'll start asking questions. I will start asking questions to panelists right now. But because it's a little too early to totally open it up. But anytime any one of you want to ask questions, have observation, raise your hand, and we will take that in. So let me start with on thermal, solar thermal. One very interesting comment that he made while he was sitting here, that most of our industry uses a large amount of oil. He has to tell us which kind of industry and all that. And he says that a lot of that is thermal energy. So you essentially use oil, convert it to thermal energy, and use it. Instead, if he is given a free hand, he says 50% of that can happen from solar and probably at a much lower cost than oil, significantly reducing the oil import. So I'd like you to maybe elaborate on that.
Definitely. When you come across any industry means food industry. Without heat, any food industry survives. See, for milk industries, if you take pasteurization and cleaning and all other things, or any mango pulp, or any food industries you account for, without heat energy, there will no food packets. And if you come across automobile engineering, so automobile engineering, before making the components to a luxury, good looking one, you have to paint it. So before that you have to pre-treat with somewhat 70 or 80 degree temperature. After that you have to get painted, and it should be dried off through oven. If you come across pharmaceuticals, you will have so many reactors and all other things which was fed with steam only. So everywhere, if you go to your home and for cooking, for the purpose of cooking, you have to need LPG. And if you go to textile, or you go to garment factory and all other things, a hotel. So everywhere if you go, without heat, you cannot make good. So by means of thermal energy, how we are replacing what are all the fossil fuels fired or CO2 emitted biomaterial. So we had to get rid of that. So we will segregate between 30 to 60 degree as hot water system, and between 60 to 90 for industrial applications, and between 90 to 150 for steam and all other purposes, and above up to 300 degree we will segregate the type of industries, and accordingly we can give you the solutions. And moreover, for a per square meter area, the sun rays falls onto our ground as 1000 watts per square meter. And if we gather that much of power by means of heat energy, you can take up to 95% of that sun energy. And if you convert to electricity, it will be around 15% only. So the net gain from the sun is the sole father and mother of all over the world and other systems, our systems. So by putting the sun as our energy source, we can get rid of, depending upon nation, I think energy security for our nations, and begging of oil from other nations, we can get rid of all these things.
Thank you. If people have questions, we'll elaborate upon that. This is a very, very bold statement. In fact, I would like him to probably put it down. So I've told him that he should send us a mail, and this could possibly open up a lot of research that how thermal can be increasingly used in industry, and solar thermal, and particularly with heat rather than converting to electricity, because if you convert to electricity, the costs become just too high. But I think this is extremely important, and it can save a lot of energy, particularly in the industry. I'm not very sure whether it can replace the LPG for cooking and all that, but but I would love to understand how you can use that for cooking also, but we need to take that further. Maybe we'll ask that question. I want to now come to the wind. Several people work in wind. Of course, he's an expert, but I think she has worked, he has worked. So several people have been working in wind. Let's kind of elaborate. I would like to hear from you, what is the prospect of wind? How do you really see this? I understand, already heard that we are the second largest producer of wind energy in the country. Manufacturer, not just producer of wind, but manufacturer, second largest manufacturer, of which is a very good, ties up with Make in India program. We are manufacturing most of the things. I'd like somebody to probably start with what all are we manufacturing for wind? What are we not manufacturing for wind? Number two, of course, he set up test labs and things like that, because turbines and what kind of things are we going to do. Number three, in terms of deployment. Number four, in terms of policy. So for a short while, if you don't mind, I will make it wind specific. Is that okay? Because I'm trying, yes, your question. So I think I will answer your solar photovoltaic a little later. But you to speak, what was the question? Are we concentrating too much towards solar photovoltaic? Solar concentration is better. We'll come to that, but let's kind of first focus on wind, okay? So who wants to start, sir? Will you all like to start by taking up? Yeah, sure. And tell us what are the different components that goes into wind? Because I think as engineers, as research scholars, we like to see what are the elements that go on to make a wind plant. My only concern about presentations and video, because I saw some of them. Yeah. By the time we run out, that's all. I thought the interactivity will go. If you can do this, if you think you cannot do it, then we will revert back to the slides.
So basically in the wind, we have all the 9 engineering disciplines involved, including chemical process and everything, as all of you know. It starts with the glass fiber reinforced plastic blades. It goes with sizes of the blades can be 178 meters diameter. It's about the largest in the world. In India is about 40 to 50 meters large, one blade. Even to take the blade through some of the rural roads is a big task. I think industry, Gamesa is there. You have to do a logistical analysis. There are companies who will do only logistical survey and report. The business in wind sector is enormous, because it is in many, you can pitch in anywhere you want. That's how it is, 9 engineering disciplines. Basically a small RPM rotor, the wind generator starts with a small RPM rotor, which harnesses kinetic energy from the wind. So the small RPM have to be converted to high RPM for the generator. So you need a low speed shaft, and some of them with gear, some of them without gear. You speed up the RPM, revolutions per minute. So if it is a 50 hertz cycle we want in the power, it's about 3000 revolutions per minute. So 2 poles, 1500, 4 poles, 7500, 750. So the gear ratio may drop a little bit with the number of poles. That's but you need a speed up of the small revolutions. So there is a gear or without gear. And then there is a high speed shaft which takes off from the gear to the generator. And the generator generates power, put it into the grid, in the right grid quality. We don't want fluctuations of voltage, we don't want fluctuations of frequency. The wind does both. So wind, as you generate from wind, it is like a cycle dynamo. You ride fast, you get a far brighter light. Variable frequency, variable amplitude, variable voltage. That's what you get from the wind if you completely use the random wind. So you need to do a lot of power electronics to control it and give it at 50 hertz to 20 volts. So that is what is important. And when you use power electronics, there are a lot of noise comes in. Filters, harmonics will come in. You have to suppress all the filter out harmonics so that no grid destabilizes. These are basically the technology in a nutshell about the wind. And we are almost indigenization in the manufacturing sector is more than 40 to 70%. We almost manufacture every component. Depending on the company's tie-up with the foreign collaborator, most of the components are either made in India or a few are still imported. That's how it is. I think industry will tell you some more details on that.
Okay. Thank you.
Thank you, sir. Well, before getting into the wind, wind is basically divided into two major sectors. One is on the onshore, another one is the offshore. What is onshore? Onshore is you are putting the turbine that is in the land. So India, as of now, we are completely in the onshore. In the future, after 10 years, there's a possibility we can move towards us on the offshore. If you are looking into the Europe or US, they already moved towards the offshore. Offshore required all the 9 disciplines, specific discipline on the civil is much more important when you are erecting your turbine in the middle of the sea. Okay. When coming to then the onshore, so he explained about the till the generator. After the generator, that will be a transformer. Transformer basically the dry type and wet type. The different manufacturers can select the different type of the transformer based on the need. Okay. All these selections of the WTG need to go the TDS certification process. One is the Germanicium Lloyd GL certification process, and they will follow IEC norms or GL 2010 norms. So both the norms will be followed when they are certifying any of the wind turbine generators. Basically, India market recent days is moved towards us on the megawatt scale. You can imagine the current tower height of Gamesa is 104 meter. 104 meter is nothing but more than 10 storage building. The tower height itself 10 storage. Above the tower, you are keeping the nozzle. And the rotor, that is the blade which we are looking into the composites, is 56 meter height. So 56 meter we need to transport through the logistics. Okay. So as of now, we are depending mostly on our road transportations. We are having lot of bottlenecks. So whenever we want to reach the site, some of the sites we have forest areas. We don't have the way to take it across the complete rotor inside the forest. So those are the real bottlenecks we are facing on the project side. When it is coming to the design, so all the generators, all the gearbox are conventional type. So it need to increase from the low speed shaft to the high speed shaft. So there will be then the tremendous amount of the lubrication is required. So lot of bearing is coming into picture. Those bearings need to work for 20 years. So those bearings need to have then the research of automatic lubrication system. But India is, low wind season and high wind season is applicable. Only 6 months we will get it across the high wind. If you are making auto lubrication system, irrespective of the wind, it will automatically lubricate the oil. So that will make it across the problem whenever we are getting into the low wind season, because the turbine will not rotate on the low wind season. For India, April to September is on basically the high wind season. So from September to again March is the low wind season. Those season we need to take care of all the maintenance. Okay, and subsequently the blade height and as well as the maintenance of the blade is also very difficult. There is no specific cleaning system is available. So there will be some research can be go towards us on the cleaning system. That can be robotics, and some of the area we will get it across continuous rain. So lot of fungus will be formed on the blade. Those things is also supposed to be taken care. It is purely on the yawing systems. So wherever the wind is coming from north to south or south to north or whatever the combinations, subsequently the yawing will automatically need to happen based on the PLC logic. And after the yawing, you need to capture the maximum wind potential with the help of the blade. So due to that, you need to do specific pitching. When you want to do the specific pitching, subsequently the blade will be slightly tuned based on the wind directions and as well as need to capture the maximum wind. So in India, the potential sites are going towards the lesser PLF. PLF is nothing but plant load factor, is coming down. One side, we are facing the issue on the plant load factor based on the availability of the land. So we are majorly focusing on 7 to 8 states. If you are taking the state across India, all the coastal area, start from Rajasthan, then Gujarat, then subsequently Madhya Pradesh, Maharashtra, Karnataka, Andhra Pradesh and Tamil Nadu. Tamil Nadu, 65% of the electricity we are getting only through wind. Okay, that's a reality in the windy season. And as well as we are strongly facing the problem on the weak grid, because India, we are having overhead lines. Even though the turbines is producing, we are finding the difficulty on connecting to the grid. So there will be tremendous amount of the research can go inside on how to mitigate this.
Thank you, sir. We'll come back to you. Okay. I'll hand over to her. I also want, while you are doing, I also want some elaboration on micro wind turbine. I mean, why with somebody, but you continue.
Yeah. Actually, I think I'll talk with the PPT on, so that the demand for the research as well as how we solve little problem using our wind tunnel facility in SCRC. And if you see the Indian power sector at a glance right now, these slides have been acquired from my friend who is in MNRE, representing National Institute of Renewable Energy. So he has given me some input, so that when I said that I'm going to talk to IIT research scholars, so I expect a lot of questions from you guys, so that you can give solution to these industries and to our nation. So if you see the Indian power sector at a glance, the total installed capacity is 245 gigawatts, and in that we have almost touched upon 13% of the renewable energy. And apart from that, if you consider little bit on the hydro, micro hydro level also, if you consider, then we have come to 30%. And if you see that the other energies from gas or thermal or hydro or nuclear, they have the pie chart there, you can see. And next. So if you see the 12th 5-year plan goal, we have to get 30 megawatt, that is 30,000 megawatt renewable energy capacity, which should be harvested through renewable energies like wind power, and we are aiming 15,000 megawatt and 10,000 from grid connector solar and 5,000 from other sources like biomass or even micro level hydro projects. And if you see electricity from wind and solar nowadays, as Saravanan was telling, that we are going for a hybrid system, then it's a challenge to maintain the balance of electricity supply as well as the consumption at all times, as Professor was mentioning, that this should be equal to. So that equation we need to satisfy. And the cost-effective integration of solar and wind energy has become a pressing challenge for the energy sector. So what is happening is the growing need for generating better prediction of wind power using weather forecasting tools. That's a must, because database have to be built up. So MNIE has already sanctioned 51 monitoring stations at various sites in India for the solar power. And if you see, 121, but this is 51 is already established. 121 is already operational. Oh, that's updated news. Okay, thank you. And with cost. Yes.
The data will be based on the cost. You will give it.
Data is coming every minute in our server, all the 121 stations.
Whether you will give me or not?
Yeah, we are definitely giving you after data quality checking process. And we have spent more than 70 crores. We have only collected 9 lakhs so far by selling data. Then you can imagine the data.
Energy data, $1,000 they are charging.
Okay, I think that's all right.
Okay.
That's a commercial part of it.
So if you see the MNRE has given certain guidelines for producing these kind of energy, renewable energy for the year 2017 from wind power and small hydro and biomass, and Bagasse is nothing but from the sugarcane industries and waste to power and solar power. So that is totally amounting to around 60 gigawatts. Yeah, next. So if you see the Indian energy scenario right now, that over 230 gigawatts, as I said, that they are aiming up to 2017, and already we have reached 13% from the renewable, and the energy shortage right now is 8% on normal period, and during extreme period it is 11%. And one, as he was telling that, oil. See, if you see, already we are importing 80% and the demand is still growing. So if you, and the next point is that per capita energy is actually 1/4 of the global average if you consider our country compared to the global demand, that is less than the average electricity demand. So, but in future it's going to be raised to 5 to 7 times. So, next one. So, what is needed is some kind of an optimized regional modeling for renewable energy. So, as a research scholar, we can get into this kind of a modeling, because if you see, you have to have the combination of atmospheric model, air pollution model, and then for the climate and earth system simulation, then cloud forecasting models. All these things should be able to develop seasonal forecast products, or you can use the existing database itself to evaluate current and future renewable sources, considering the boundary layer premises or effects and complex terrain, low level jets, etc. And the model should be able to predict the weather for energy generation and variability. And another one, you can have a renewable energy test bed to improve fundamental understanding of the mesoscale and the local variables in this thing. So what we have done using our internal is, for example, for a wind turbine, we have evaluated the wake pressure, how the variation of velocity behind the, because usually in wind turbine they measure the velocity near the generator, turbine. So how much loss is there considering the approach flow. So that has been measured in the wind tunnel using boundary layer wind tunnel. And the second photo that you see is we have tried to design that turbine blade for harvesting low wind. So we have to produce the power curve for this particular configuration of wind turbines. So these kind of research can be done. And when it comes to solar panels, some of the work have been done in Japan, that the rays of solar panels, how the wind forces or the suction forces coming onto these panels, that is using wind tunnel. So they take 1:100 scale down model of solar array, and if you see that, you can even find out what is the peak wind forces coming to the supporting structure. And the same way, you can see that some of the studies, even using CFD, have been studied on solar panels, which is done basically at CBRI. They have some of solar panels on the tower of a lab, and they have come out with the panels. So if you see that the whole kinds of energy, renewable energy that have been gisted, this is basically from MNRA as well as TERI. They have asked me to project it just to show that decentralized applications of solar, biogas, cook stove and would be widespread, and energy access in rural areas is a priority. So the target given by the government is 5,000 villages, and new avenues of setting up micro-hydel projects also has been encouraged, and waste to energy, as Professor was mentioning, and bioenergy and waste power generation, and more application of hydrogen fuel cells also, and no estimate of offshore, as Saravanan was telling, that no offshore. First of all, database is missing in offshore wind potential. Okay. Thank you.
Thank you. So will you like to say something on wind more?
I would like to say that most of the wind turbine manufacturers in India, that is 20 wind turbine manufacturers out there, most of them are having some foreign collaboration, something like that, the technology transfer or licensing or purchasing of design rights. So most of the designers of wind turbines are from European countries. So they designed their wind turbines which will be operate better in the European wind situation. Our wind situation is somewhat different than the European countries. So as a researchers, you may have to do various research on indigenizing the wind turbines, which is most probably the India specific design needs to be done, so that we can get more efficient, efficiently we can extract wind energy. That is one of the key challenges in the wind energy sector.
I think I would just throw a highlight on what specifically what he is saying is, every wind turbine is designed for a particular rated wind speed to give a rated power. Suppose 2 megawatt means 12 meter per second wind speed, it will give you 2 megawatt. Until that time, it will be only ramping up. After that also, up to 25 meter per second, it will give the same 2 megawatt by control systems. And then it will go. The rated wind speed, what is available in most of the wind turbines in India is 10 to 12. And if you see, some of them even cross 12. Whereas annual average available wind speed in India, anywhere in India, is around 6 to 7 meter per second. So you need to bring down the wind availability, the wind peak to the rated wind speed, rated power peak of the machines. And that's what is so India-specific design.
Yeah. Thank you very much. Will someone look at, talk about micro wind power? Is there anybody who wants to talk on micro wind power? Please, can you do that? On micro wind, is it possible that, see, solar we now start putting on every rooftop. Is it possible to put wind on rooftop? At least of the tall buildings, can we do that?
Yeah, when it... Yeah. So when it comes to micro wind turbines, actually the targeted capacities will be very, very small. Like Professor was telling initially 500 watt solar panel. Similar to that, we can have something like as low as 500 watt to 2, 3, 4 or 5 kilowatt. Kind of the capacities are aimed. But the only issue is that one is manufacturing of good quality micro wind turbines, and the next is availability of wind. Mostly these micro wind turbines are meant for either in urban environment or in rural where there is no grid. Basically, these are very good where where there is no grid connectivity is there. There you can make use of these micro wind turbines efficiently. The only issue is that good quality and efficient wind turbines are not there, and popularization is also, there is a lot of
so this is exactly my question. The entrepreneurs, there are, I don't know how many of your research scholars or students here want to become entrepreneurs. What does it take to get high quality micro wind turbine done, kilowatt, 2 kilowatt, wherever there is wind? For example, Chennai has enough wind. Can we have most homes or half the homes in Chennai start using a wind turbine? What does it take to manufacture? What is a challenge in making a good micro wind turbine? Anyone? Huh?
Yeah. First of all, the challenge is that cost of the wind turbine in relation to the capacity, because everything boils down to current scenario is that in comparison to conventional power usage, you have metered charges are there, but when you replace with alternative technologies, commercial viability is one thing. In that process, everybody looks at 1 kilowatt, what is the charge of the wind turbine and what are the returns for me in comparison to investments. And the next thing is that whatever is available in market, the wind turbines, even though they advertise for very high capacity, but when they are tested, they happen to be very low, efficiency.
I like Gomathi Nayagam.
Yeah, I think the micro wind turbines, in the last 20 years, the total installed capacity, how many of them are operational, I don't want to tell you. The total installed capacity is 2.3 megawatt. That's all.
I think don't worry about that. The point is, it is
very low.
If a good design is there, today people are moving towards, today they are, see, 2 years back, solar PV was hardly there. Today, solar PV is going. Wait for 3-4 more years. You will see the solar PV. I'm asking the same question. What is the challenge involved in making good small wind turbine? If the cost is a challenge, that's a challenge that our students would like to take up.
Yeah. First challenge is the market, number one. Number two is, unlike the solar panel, which is like plug and play, to have your own power, the wind turbines require some skill to operate. It is a little noisy in the habitat. So you need to design silent wind turbines, omnidirectional, and more than 1 lakh models are available in the website. If you just browse aero generators. But none of them are, there are very few companies in the world making business in wind turbine. But the prediction is that in the next 5-10 years, there's going to be a tremendous increase in US and Europe for micro wind turbines. About 20% rate of growth is envisaged.
Why US? Why not India? And
we should.
This is the challenge that I would like to sort of say.
Yeah,
why not India?
Yeah.
Why not? I'm sure Indian designers, our capabilities are very high. We should be able to come up something and we should be able to supply to the world.
Yeah. Only human brains can think, and not the parallel computers which need to be programmed to think. So you have to innovate. Innovation is the key. Yeah.
So I think it's almost 7 o'clock and I want to move to solar PV and associated hybrid. So I already told you right in the beginning something about solar PV, the potential of it. I think there are two parts of it. One is a centralized plant, another is a decentralized plant. Decentralized plant, there is nothing better than that. I don't think in terms of, as you say, there is nothing better than plug and play. You buy something, put at each home and start using it. You have seen today the rooftops of ESB, MSB, HSB. If you have not, look at it. What have we done? We have 1 megawatt of plant. Almost 15% of the total electricity used by IIT is being generated now. This happened in practically no time. And this is only a fraction of the rooftop. It requires very little for us to say we'll generate pretty much all our electricity. Because all the hostels are there. We can do that. Second, I'm sorry, I'm taking a little bit of time. Some of us have started working. I have started working 2 years back. I'm not in power area at all. I'm in a communication. I've done wireless in local loop and things like that. My colleague Bhaskar Ramurthy, who happens to be director also, started working along with me. And we, of course, several power electronics people added. The power electronics is a key area that is starting to make a breakthrough. But a lot of breakthrough comes because of power electronics. What we did is that we suddenly figured out that solar PV produces DC power. We use AC power, so we convert DC to AC. And when we convert small amount of DC power to AC, we lose about 15%. So 15% losses are there. But normally solar power can fluctuate. So associated with solar power, generally there will be a battery. So if you put a battery also stores only DC energy in DC form. So we convert AC back to DC. And then when we take the energy out of the battery, it's again a DC energy, we convert it back to AC. And when we started looking at it, we are losing almost 50% of power in the process, 45% of power. The second thing that we figured out is that appliances are slowly shifting to DC. This is very surprising. For example, these lights are CFL tube lights. Future lights, all of us know, are LED. Why? Simply LED is 2.5 times more energy efficient than CFL. But LED only requires DC power. So what if I have AC power? I do another AC to DC conversion. My laptop, my television, the screens, all electronics, cell phone, everything works only on DC. And I use converters. We lose 30, 35, 40% of power in doing that. Why not use directly DC? We then came across fans. Fans is a major. It uses induction motor. It's AC induction motor. That's where we need AC. But that's where the power electronics made a difference. My colleagues started talking about brushless DC motors, SR motors. And suddenly we found, oh, we can make DC fans. And we got the companies to start making BLDC fans for us. You come to my department. Why my department? The new hostel, the top floor of the hostel has all DC appliances. All DC. I don't know whether the women's hostel, the girls' hostel, has DC line going in. We have quietly done it. People don't even realize it, except we have also given them a small remote. So they are thrilled with the remote. I've seen many, many videos, people talking about it. So again, converted to DC. Now when we do that, we save another AC to DC. So what we do, first of all, we save 50% of power because of AC, DC, DC, AC, AC, DC conversion. Second, we save another 50% of power because we are using this BLDC fan consumes only 50% power of an induction motor. And this is not limited to the fans. Same thing is happening to your television, your washing machine. Same thing is happening to your refrigerator. Same thing is happening to the air conditioner. Because AC motors are being replaced. Lifts today are DC motors. The cooling systems, if you buy chillers, it's using DC motors. DC motors or variable frequency drive AC motors, which is essentially like a DC motors. So this can make a huge difference. The whole DC is reborn, as he points out, and in fact IIT Madras is driving it. Sometime if you want, we can tell you what we have been able to do. We have been able to define whole variety of things. Now, what is more interesting about that while we are driving this, the solar can make a decentralized solar can make a huge difference. It really doesn't matter whether we get 18% or 20%. How does it really matter? Because I'm not talking about huge. I'm talking about 2 square meters to 4 square meters. If you're using 4 square meters, what is if instead of 4 square meter you use 1 square meter or 1.5 square meter? Does it really matter on my rooftop? Second thing that we learned. Second, if you see what we did, if you look at what we did at IIT, is that we did not put the panel directly on the rooftop. We built it at a certain height. I don't know whether how many of you have noticed that. You go to the rooftop and check it out. Why did we do that? First of all, the rooftop became completely usable. Our rooftop became usable. You can do all kinds of things. You can have a coffee shops. You can have all kinds of things. You can have a get together. Then it's a shaded place. It is no longer direct sun falling. It becomes a better place. Rooftop becomes shaded. In Chennai, shaded rooftop are very, very interesting. The next important thing that happened, because we put that and on the top floor, and the wind is flowing through that, the heat, the roof is not getting heated. As a result, the floor below, the air conditioning requirement has gone down to half on the floor below. So I think there are huge benefit. Simple innovation, very simple. Instead of directly putting on the rooftop, see, in West, people build rooftop where nobody can climb on the roof. So fine, they directly put it on the rooftop. Why are we doing it? Just putting it at a height, you watch, go and see what we have done. So I think a lot of very innovative things can be done. I'm not going to talk about, we are doing a lot more innovative stuff on that, but it has a huge, huge potential. That's what I want to point out. But I think I will then ask my colleague to talk on solar PVs and the hybrid. And we'll then start taking questions.
Thank you, sir. So first, I just want to point out one information that Dr. Selvi Rajan had showed. 10% of installed capacity is from renewables. That is in terms of power. But in terms of energy, because the plant load factor, solar is only there for 7 to 8 hours, still much lower, less than 3%. So I think that's something that we should really keep in mind when we look at these numbers. 10% sounds very high, but in terms of energy, it's significantly lower. So the area that we have been working is marrying this solar PV, the new kid on the block, which got a lot of attention, with solar thermal, which has lost attention, to see if we can marry these two technologies. And so you can ask me, why would you want to do that? So if you see, a lot of rooftops have solar water heaters. The reason why they became popular is that because they're cost effective and they can provide water at a subsidized, heated water at subsidized cost than your electrical heater. Right? So I think the economics has to drive any solution, not the subsidies. So as Mr. Manoharan said, solar thermal without subsidies he can do. So we started looking at some of the industrial applications, why you would want to do this. So if you know, the electricity prices, the consumer electricity prices are very different than industrial electricity prices. There's a factor of 1.5 to 2 difference. So the question is, can we produce electricity and heat simultaneously for industries at a reduced cost? So one option that we were looking at, okay, we'll take solar PV panels, but still expensive, 80 to 100 rupees per unit per kilowatt hour, per watt, sorry, and probably 50 to 60 for the heat. So the question is, if you operate these solar panels under concentration, so you just put mirrors on the sides, increase the concentration, then you can produce a lot more power from the solar panels. So then the question is why people are not doing it. Because since most of the solar panels are made of silicon, which happens to be very inefficient material at conversion of sunlight to electricity, so it's only 15 to 20% efficient. So the rest, 80% is just heat. So when you operate the solar panels under very high concentrations, you produce a lot of heat and you degrade the solar panel, supposedly 25 years, right, to less than 10 years. So what we have been looking at our lab is to use a solar panel under concentration and put a heat exchanger system below the solar panel, which can effectively trap or exchange the heat that is produced by the solar panel and use that heat to produce an 80 to 100 degrees C water. So when we looked at this idea, we found out that if you can successfully do it, that's where the research challenges lies. If you can successfully do it, you can reduce the cost of solar PV by 20 to 30% just by a small addition of mirrors and integration of solar PV to thermal. I think this is a very interesting area where there is a lot of research scope, and marrying such technologies will significantly bring down the cost of renewable energy.
I think with that, I think each panelist have kind of spoken. I know they want to speak more, but I think I'll open it up for question answer. Please, you had some question? Yes. Can you please take the mic so that?
So you talked about this the DC power generation using this. So sir, like if we have decentralized DC generation, a usage of DC, then we can use the solar panels and then directly we can do. But when we have a centralized solar panel, solar generation system, then we have to do that transmission of the power. And the DC transmission, that's very inefficient. So then sir, how can we mitigate that?
Okay. So first of all, go step by step. We are currently not talking about changing the grid and changing the transmission, because changing the grid and transmission is a long-term and expensive proposition. If it has been built, let it be there. We can keep AC grid, but at home convert to DC, add solar, and run the home grid on DC, or run the office grid at DC. So home and office is huge. We haven't worked enough on industry. I think industry will also benefit, but home and office we can do immediately on DC. It can be done today. My home, 50% of my home is DC. My office is only DC. I don't have AC in my office at all. AC power. You can come and see it if you want to. Even I have a television, I have my laptop, my fans, lights, everything is on DC. Now, having said that, let me talk about something else. I think it is a thinking that DC is more lossy in transmission. That's not true. Long distance transmission lines, high voltage transmission lines are now only DC because they are less losses than AC. Let me tell you why. AC power, particularly when it's high voltage, essentially travels on the skin of the wire. On the skin of the wire. So the resistance that it faces, because it's only seeing a limited amount of metal, only the skin. So the resistance that it sees is much larger. Whereas DC transmission travels throughout the wire and therefore is less lossy. Do we see 50 years down the line that we will have a DC transmission? I don't know, maybe. Complete grid can be DC. But today long distance transmission, high voltage long distance transmission is already DC. So I think don't get stuck by this simple thing. The important point is, let's look at start with your usage. What do you use? You use your laptops, you use television, you use cell phone. All electronics is only DC. Any electronics that you put, even you put small sensors, it is all DC. So all electronics will be DC forever. Well, I shouldn't say forever because we don't know what, but I can't conceive of because there's nobody even working on that. LED lighting is moving to DC. As I told you, motors are moving to DC. So if all these things move, and motors have become DC motors have become possible, and DC driving has become possible because of the power electronics. Power electronics integrated circuits. That is what is making the whole thing work. I want to also point out DC as another very important thing. The power factor issue goes away. One of the biggest problem today in power is that we have a poor power factor. In India, particularly very poor power factor. As a result, a whole lot of, I don't know how much of you understand, if a power factor is 0.8, 1 by 0.8 of the power is just wasted. Whereas in DC, there is no issue of power factor. So there are advantages. Let's go step by step. Home, offices, and maybe industry start moving to DC. Then let's look at what else can be done.
Yeah, I think
but questions, other questions? Yeah, please, go on.
I agree with you because if you have only one shift office, which works only in the daytime, you need just some lighting, some power for working for computers. Definitely DC can solve your problem. The solar panel will work 5 hours, and little bit of storage can extend the working hours a little bit. Office is the first priority, we can do that. Home, people may not be in the home because they will be in the offices. Urban homes, yeah.
Well, the world keeps on revolving. Next question.
Good evening, sir. Sir, my question is related to wind energy section. Sir, when we are talking of converting and getting energy from wind and all, there are concerns regarding the noise which has been produced by the wind turbines. There was a recent survey in Denmark which was showing noise level to be increasing due to the use of these wind turbines. Also, the climatic conditions and the weather have been changed. What are your views on that? What are the concerns?
The wind turbines do produce noise when the RPM is very high. But we have an international standard for noise measurement, acoustic noise released by the wind turbines. And we have proved a couple of instances where customers have claimed noise. It is less than 40 decibels, and which is much less than what we tolerate as noise in India. Okay, it is more than hundreds of decibels we tolerate everywhere. You go anywhere in India, the most silent place probably Matri Mandir in Auroville you have to see. That's where you'll have almost 0 decibels. Otherwise, the decibels or permitted decibels within a particular range is about 40 decibels. And small wind turbines, micro wind generation, they will produce noise. And that requires little bit of acoustic enclosure or redesign. Because their RPM is high, they are cutting the wind in a turbulent wind, that will be noisy, little bit noisy. But I think we tolerate a lot more noise. So noise reduction is important, I agree. But wind turbines, today the modern wind turbines, megawatt class wind turbines, they are very slow of RPM, 18 or 15, 20 RPM, revolutions per minute. Even birds can escape that velocity, and birds don't get hit. 0.4 birds only get hit in wind turbines. We have money more in the traffic and transmission lines and substations. So noise is not a serious thing in the megawatt class machines, but small ones, yes. No. I think there was a Maharashtra MPs made a big hue and cry of that a few years back. But see, we are dealing with, when you say weather and climate, it is what's happening in the upper air circulation is about 2 kilometers away from the surface. What we are harnessing today at the maximum 150 meters above the surface. And the whole wind is caused by solar. Wind is the maximum installed in renewable all over the world. But the entire wind is caused by 2 to 3% of solar radiation on Earth's surface, differentially absorbed in different surfaces, which causes wind, air to move from place to place. That is wind. So the wind is caused by solar.
Yes, you have another question, please.
Good evening, sir. I have a couple of questions to Jhunjhunwala, sir. First thing is, you talked about the 1 megawatt installed capacity in IIT Madras. Could you shed more light on how much did it cost, how many years will it last, and how does it compare to your thermal thing? My second question is, all your photovoltaics, when you're trying to scale it to such level, it is all semiconductors. Maybe after 15 years or 20 years, what are we going to do with that semiconductor? Because
to do with the
unused solar panels, and is there a system in place, or does it need scaling up, and how do you what are the challenges in those lines? Could you shed more light on this?
So how much did it cost? If you calculate the solar panels that we have used, 20 years we will get power at least. It can go beyond that, but 20 years is the lifetime that we have taken. It actually can go beyond that, but 20 years there will be a minor reduction. Beyond that there can be a somewhat higher reduction of power. Now taking that into account, 20 years, and taking into account the Chennai sunlight, and if you then calculate the total amount, our average cost, if you have invested, and we will depreciate and recover the money, you keep that alone in mind, but not keep the any interest, because we haven't paid any interest and all that. Our average cost will come to around 5 rupees per unit. Today we pay higher than 5 rupees per unit. Now remember, today we pay higher than 5 rupees per unit. 5 years down the line probably we will pay 8 rupees per unit, but we will be generating still at 5 rupees per unit. If you take interest cost into account, at interest, suppose you had borrowed that money from the bank at around 12% or something like that, then it will be more like 6 rupees per unit, 6.25 rupees, 6 rupees 25 paise per unit. That's the kind of cost, economics of today, the kind of plant that we have done. Part of our plant that we have used is experimental plant, where we are using solar panel from 6 different manufacturers, and we are testing the different things about them, about their lifetime, about their efficiency. If we are using amorphous versus crystalline silicon. So that part is a slightly more expensive, so I'm not taking that into account. But the rest of the plant is, this is the cost that we have. A very interesting question, what do you do with the solar panels in terms of when the lifetime goes out, can you actually do recycling, can you do waste disposal? There are enough techniques today to pretty much recycle much of that and also do waste disposal. Though I will sort of say that far more will happen in the next 4 or 5 years, 7 years. A lot of research is going on how best to do that. Only the silicon part is actually removed. Problem is far more what will we do with our cell phone waste. That is far more, because I think cell phone is going to generate far higher waste than that happens. There is some focus, not enough focus. I think more R&D is needed on what to do with electronic waste disposal. I am more concerned electronics part, the silicon part, the chips part itself, there is some reasonable work done, more needs to be done. But what do you do with cell phone, with packets and batteries in the cell phone? I think that's something that is a little more concerning.
Here the area is more, right? Compared to your cell phone area, the area of your panel is more, right? Every house.
Sorry?
The area of the panel is more,
surface area of the panel is high.
Surface area of the panel is not that high. Surface area of the panel is not, for 1 megawatt, we haven't even used all of HSB, MSB and ESB. We have not even used.
No, physical size of the panel is much more than the cell phone.
No, but that's all right. That it can be broken, cut. Well, I don't think that in itself is a big deal. But actually, even the panel has a strengthening material. That strengthening material, nothing much can happen. Now, you may then ask me what can happen to the building material. So I think one can go on, but those kind of things are basically, there are aluminum or other things which are kind of anyway can be also remelted and used. So some of that can actually be done. But there are parts, the silicon part is what I was focusing on, which is what the most problematic part. Other parts are less of a problem. Okay? But yes, more work needs to be done. Electronic waste disposal is something that not enough has been done. Electronic waste disposal, I am sort of saying that our laptops and our computers and cell phone are far bigger problem today than silicon panels.
So regarding disposal, like Professor has mentioned the 20 years roughly lifetime. It's not like after 20 years the solar panel output will go to zero, right? It's,
by 15%, 20%.
yeah, exactly. So it can be given away to people in need when if you find that there are cheaper options for the available rooftop space.
For example, IIT would continue to use them. I can see at least for 26, 27 years, 20 years. Beyond that, one has to see whether we want to replace by better panels.
Sir? Yes. Sir, as you said, during the dual conversion, before giving the supply, which is derived from the solar panel to the battery, we need to convert it because considering the fluctuations of the weather conditions. So, due to this dual conversion, the efficiency goes down like anything. So, why can't we focus on the regulation of the voltage parameters while itself feeding to the storage device instead of changing the full system?
That's exactly what we are doing. We are trying to make a complete solar DC system where we eliminate all the so if you come and see, we have designed complete solar DC system where we from the solar panel to the battery to the usage, everything remains DC. It's not non-trivial because a lot of small power electronics is involved, because the voltage that battery requires is slightly different from what the solar panel voltage, MPPT voltage keeps on changing. So I think we still have to do a little bit of fine tuning, and that's where the power electronics can do. I want to bring back the focus back on solar heat, because I think that's the most, you have some, anybody has questions? If not, we are coming towards the end, and when we are coming towards the end, I want to bring back the focus on solar heat. What do you think solar thermal and particularly use of solar thermal in houses? He mentioned that you can actually do for cooking. I'd like to understand a little more from him.
Sir, in cooking, steam cooking is a best thing. For steam cooking, you need only steam. And our pressure cookers are operated at about 2 bar pressure, which means around 120 degree to 130 degree. And our frying, the pan frying and all other things are between 150 to 160 degree. So you can do, if you have a source, just like battery, if we have energy at 160 degree, you can entirely forget your LPG gas. So through solar, you can harness the heat, and through PCM, phase change materials, you can store up to 160 degree centigrade in your house itself. So from that energy, you can get all the things in cooking, frying. And one more thing, for air conditioning also, from heat energy to air conditioning, I think it is available through vapor absorption machine. And another thing, you can generate electricity also from there by ORC, organic Rankine cycle engine. So what you need in your house? You need power, you need heating, and you need for the cooking and air conditioning. So if you completely fulfill these needs, it will be the independent house. And if at all rain and all other monsoon times, you can make use of your conventional energy. So for a year, 300 days, you can make use of this solar energy for your home needs. You think, see, throughout world, if you take care of all your home needs, then the energy requirement will be drastically reduced to 10 or 20%.
So let me challenge you, sir.
Yes.
I know that you and I are getting older and may want to eat boiled food, steamed food, but not everyone only eats steamed food. Steamed food is a component of our food, but we also use a lot of, we make chapatis, we do frying things, we even fry the vegetables. So I think we are not going to change our eating habits. And so I think we have to figure out whether something more than steamed can be done. Steam part is known. It is solar cookers have been there, not taken off very much, but that's only a small component, or a certain component, but a small component of home cooking. Please.
Yeah. So it's a very important point, because as users, right, we don't want to change our habits. Right? We just want the same stove to cook the same thing that happens. So the biggest challenge, we have worked on an in-house solar cooking design. So basically when we looked at it, we said, okay, you are converting a 5000 Kelvin power from the sun into 100 degrees centigrade low-grade energy. For real cooking, you need at least 200 degrees C so that we can use fry and stuff like that. So one way is we said, okay, we'll delay converting that sun's energy, right? Instead of steam, that is 100 degrees, you can transport the light energy into the house. And then at the point of the stove, you can have a phase change material which can absorb this sunlight and convert it to 300 degrees. That's one approach. Another approach we said is, instead of using optics, because light transmission is not as effective as heat transmission, it's lossy. So you can have a heat exchange fluid like oils, which they have been working on, which can be heated up to 200 degrees centigrade and can be transported inside the house and can also be stored. So what do we do with the night time energy? So these are where research challenges are.
Yes.
Through PCM, if you store in a container with the help of non-gravity heat pipe, you can directly give your heat energy to your frying pan.
Okay, so I think
I have made.
I'm very happy to learn more about it, and I want to move and give the panelists last 1 minute or 30 seconds each. We are almost out, 7:27. Also, those who love cricket, Chennai is almost won the match, so I think we need to wind up and probably go do something else. So before I wind up, I want to point out that there is an interesting work being done by youngsters of your age group. About 3 or 4 of them met me from Trivandrum, and they are now taking our help. They are essentially using water and actually to cooking by, and solar is the heat that they are going to use for that, essentially generating hydrogen and converting it to hydrogen and then using hydrogen gas for cooking. They have actually made things. They have actually made things which is working. And so, what I like about that is that totally out of box thinking. You know, whether it's finally going to become, because finally everything has to be economical, but they believe that it can be economical. And these are youngsters who are trying to do totally out of box thinking, and now we are kind of helping them. They are doing it with electricity. Now we are trying to see that the solar can actually be used for something like that. So there are all kinds of things can be done, not the conventional thing. That actually makes it very interesting simply because it's a totally out of box thinking. And I think one of the things that I would like our young research scholars to do is to keep on looking at totally out of box thinking. With that, I will just give 30 seconds to each of the panelists. If they want to add something to the panel discussion today, we will do that, and then we will wind up. Start.
The major bottlenecks on wind energy sector is to create a good forecasting models for India specific. That is the next trusty area which we need to move forward, because the wind power is not consumed by the state electricity board due to the fluctuation in nature. So we don't have a good model to predict the wind that much accurate, because that power is cubic time relationship with the velocity. So small change in wind power production means then it will be a lot of difference in the power production. So we have to do a model specific in India, and we are working with a foreign collaborator to develop such model. It's on the way. Since you people are from researcher, so you may have to do some research on developing wind power forecasting model specifically for India. Thank you.
So, especially in my area, you can work it across on the foundations on the hybrid side. On as of now, we are mostly using the steel towers. You can work it across on the concrete with the steel tower mixations. That is the one area you can work on the civil side. On design part, you can work it across some sort of the heat transfer. Especially the area like Rajasthan, we are facing major issues on the high dust and as well as the high temperature. We can identify some sort of the solutions towards that. And project executions, one is on the weak grid. Subsequently, we need to look into some good proposals, how to make it across on the weak grid. And on the service side, theft issues. Majorly, we are facing the theft issues. Most of the time, the turbines are running on the remote locations. Work it across on some sort of the logics. On especially on the blade cleaning, tower cleaning, or remote blade inspection tools, or bolts. Most of the places on the wind turbine using bolts, bolt loosening and alarm systems and generator gearbox alignments. Those type of the areas we can explore and get it across as some hybrid proposals.
Yeah. In the case of micro wind turbines, the challenge I feel that the wind power is proportional to wind velocity cube. Okay, so there is a 10% increase in velocity can lead to 30% increase in power generation. But we don't have any control on the nature, that is on the velocity of the wind. But using bluff body aerodynamics as a triggering mechanism, that is by providing bluff bodies before the wind turbine in a strategic way, and you just speed up the velocity when it hits the turbine. So you can achieve a lot of increase in the power generation. So I feel there's a lot of research scope is there in working in the AC area, because this is very, very wide open research. It's not like any conventional thinking is well saturated. So there is a lot of scope for lateral thinking and coming out with new ideas in the case of micro wind turbines. Thank you.
I think renewable energy has a lot of promise. We use in our campus all sorts of renewable energy. We use SPV directly into our LT side grid, reduce our electricity bill. We use our sewage treatment plant to give our kitchen methane, biomethanization. Through biomethanization process, we get 8 cylinders per month, almost. Our own sewage and kitchen waste is being returned to our own kitchen. And we also have a small wind turbine. And there's a lot more to do. Just now, I just reviewed a project from Delhi IIT people, Delhi, some private institute, where they have used levitation, magnetic levitation as the bearing for a Lotus type of a small wind turbine. It is available in the YouTube video. You can see the project. It's an excellent project done by 3 people. And it is commercially also it's possible to be viable. That's why human brain can think and come out with a lot of ideas. Yeah.
Okay. Whenever I think about renewable energy, I get it's a very scary picture, because as human beings, we don't want to change the usage patterns. And for the next 20, 30 years, I think we're still going to be a coal-based economy. Sorry to be a skeptic, unless something drastically really happens, right? We still want to, this room is a great example. As a student of IIT, I used to come to this room so that there's nice AC and probably lights are dim so I can get good sleep, right? We don't need, right? It's very hard to change people's habits. So the only comment I would like to make is, as young people, I think all of us have to be conscious of our energy usage. And the current generation of energy is very inefficient, right? 5 watts is generated at the coal power plant, and by the time, energy is used at the coal power plant, by the time it comes to the home, it's only 1 watt. So I think, I'm optimistic, but cautiously optimistic. But I think as individuals, we can change our usage patterns and conserve whatever energy that we can. Thank you.
Again I emphasize that as a civil engineer, what I can do or what we can contribute, and Saravanan was telling that it is a multidisciplinary work in, from all the engineering practices should join together for the renewable energy. In that aspect, our boundary of internal facility, as I was telling, that can be used. And for example, the question asked by you on acoustic, one research scholar from MIT has done an experiment, but there what the difficulty that we found in decoding these kind of systems is instrumentation for the measurement. The correct parameter, how to measure using the specific instruments. So as I was telling that it involves even power as well as electronics and instrumentation also for the research purpose. Thank you.
Ourselves and CSIR are jointly working for all these projects, PCM storage and utilities and heat pipes technology. So there are a lot of research has to be done for the welfare of ourselves and to the world. So any researchers can join with us and do the research.
Thank you. I don't have anything to add except sort of saying that renewable energy is going to become extremely, extremely interesting field in years to come. Because we are going to move towards renewable. I believe that by 2030, 50% of our power will come from solar. 50%. So India's power I'm talking about. So I think I would welcome that people looking into this area, getting into all kinds of things. The only thing that I will sort of say that whatever work you do, whether you work in wind or in bio or whatever, one of the key thing, if you are talking about electricity, role that is going to be played is by power electronics. Pick up a little bit of system level understanding of power electronics, not circuit design, because that may play an important role, that you can actually do this. It's in conversion, voltage conversion, frequency conversion, all kind, in every system that will be required. And I think that is going to play an important role. It will going to play a very important role in an industry. It is definitely going to play in all, pretty much everywhere. I'm not very sure about cooking. As of now, I've not seen much. But even there, with induction cookers, etc., power electronics is going to play a very important role. So that's one area to watch. It is something that we will see lot of interesting things going on. Thank you very much.
I thank all the panelists for enlightening us with their experience and thoughts and motivating us towards innovation in this field. I thank all of you sitting here for attending this event and making it a success. I thank you all. Now I invite upon Shipra to conclude for the day.
Thank you, Munish. Now we have come to the end of the third edition of Research Scholars Day. In this Research Scholars Day, we had so many talks, many interactions, many panel discussions, and many workshops. So I hope that all the events have turned to be a good platform for researchers to gather information and new ideas from all the renowned experts in the field. First of all, I would like to thank all the panel members for taking their time from their busy schedule and coming here and sharing their knowledge about renewable energy with us. And secondly, I would like to thank the audience to make the third edition of RSD to be successful. And finally, I would like to thank organizing committee members, all course and coordinators, and especially Manikandan, who has made all the efforts to make this event successful. I want all of you to give him a big hand. Once again, we thank you all, and with this, we will close this event. Thank you all for joining us. And I would request all our panel members to have a group photo with all course and coordinators. So I request all the course and coordinators to come on the stage for the group photograph. Yes, sir, sure.